Lesson on the modulus function and graphs of the modulus function. We'll start by looking at some transformations of graphs. So let's have a think back at what we already know about transforming graphs. There's the different transformations we've already learnt in A-level maths. The two translations, which we show by the column vector A over B. The two reflections in the x-axis and the y-axis. And the two stretches in the y direction and in the x direction. You really need to know these well, so have a read through, and if necessary, go back over the lessons on transforming graphs and make sure that you thoroughly understand the effect it has on the graphs and how we describe those transformations. Here's an example, typical of the type of question that might crop up in an exam. Describe a sequence of two geometrical transformations that maps this graph, y is the natural log of x, onto the graph of y is 4 times the natural log of x minus e. Have a go at it yourself, pause the presentation. Okay, hopefully you were successful. This is what you should have got. Okay, so let's move on to the modulus function. We're going to look at what the modulus function is. We're going to make some calculations involving modulus parts of equations. And we're going to have a look at graphs of the modulus function and transformations of these graphs. So let's start off with what we mean by modulus. This is how we write it here with these two straight vertical lines around what we've got the modulus of. So this is the modulus of x, and it means the absolute value of x. In basic terms, its distance from 0. And for that reason, it's always positive. So, quite simply, the modulus of 4 is 4, because 4 is 4 from 0. And the modulus of minus 2 is 2, because minus 2 is 2 from 0. So, what's this? Modulus of minus 7 plus 5. Well, for these sort of calculations, work out the modulus part first, and then solve. So we've got modulus of minus 7 is 7, plus 5 is 12. More complicated then, looking at a composite function, we've got f of x is the modulus of x minus 3, g of x is x plus 1. And we can see here a step-by-step approach to working out gf of minus 2. So the first thing we do is we identify the composite function. So gf of x, well that's g of f of x, so we put the f of x in instead of the x in the g of x. Remember how these work, these composites moving from the inside to the outside. So f of x replaces x, so instead of x we've got x minus 3, the modulus of x minus 3, and then plus 1. We then place the minus 2 in there, so we get the modulus of minus 2 minus 3 plus 1. We then calculate the modulus part, so we simplify it by calculating it out. Well, minus 2 minus 3 is minus 5, so we get the modulus of minus 5 plus 1. And then finally, as we know, the modulus of minus 5 is 5, 5 plus 1 is 6, so we found the value. Right, we're going to have a look now at graphs. First, we'll start off with a nice simple one. We're just simply looking for the graph of mod x, the modulus of x. So for our y values here, place in the values that modulus x will give us. So if y equals mod x, mod of minus 3 is 3, etc. Have a quick go at it. See if you can plot the graph. In the lesson I'll show you how to do these graphs on your calculator and how to solve modulus equations on your calculator. But for now, just try putting the values into the table and drawing out the graph. Okay, you should have ended up with something that looks like that. So that's the modulus graph. This right hand side, the positive side, you'll recognise as a graph y equals x, but then instead of continuing down there, the straight line graph reflects in the x-axis like so, and that's the effect that the modulus signs on turning the values positive. So the modulus function has this effect. When x is greater than or equal to 0, mod of x equals x, but when x is negative, is less than 0, mod of x changes the sign of x. So we get mod of x equals minus x. And this leads us to the modulus always giving positive values, as it's the distance from 0, remember. There's examples of modulus graphs. Okay, have a quick go at this question. The answers are on the following slides. So pause it, have a go, and then have a look at the answer to check. Now try this one. Same again, pause the presentation and then check your answer. Now try this one without graphs. This is solving. So, quick recap. The modulus of x means the absolute value of x. It's written in this form here. It basically means the distance from 0, and it's always positive.